Have you ever wondered why objects, regardless of their weight, fall at the same speed? It's a question that has puzzled and intrigued thinkers, philosophers, and scientists for centuries. A question that seems simple enough, yet holds within it the key to understanding the very laws of nature. The path to the answer is a journey back in time, a journey to a world where science was just beginning to unlock the mysteries of the universe. This journey leads us to a man named Galileo Galilei, a man who dared to challenge the conventional wisdom of his time, a man whose curiosity and determination would forever change the way we perceive the world around us. This is not just a story about a question and its answer, but a story about the relentless pursuit of truth. It all happened in the 16th century, in the city of Pisa, Italy. Picture this, a tall, leaning tower in the heart of Pisa. Galileo, a young physics scholar, stands at the top. His eyes are alight with curiosity and anticipation. In his hands, he holds two spheres of different weights, each one carefully selected for this moment. The tower, with its peculiar tilt, provides the perfect backdrop for an experiment that's about to challenge long-held beliefs. The crowd below watches in suspense, their eyes following Galileo's every move. The city of Pisa, usually buzzing with activity, is eerily quiet, as if holding its breath. Galileo, with a determined look on his face, positions himself at the edge of the tower. He extends his arms, ready to drop the spheres into the open air. The spheres, one heavy and one light, hang in the balance, poised for their descent. What do you think happened next? Galileo released the spheres. Both started their descent towards the ground. The moment was thick with suspense. The two spheres, one significantly heavier than the other, were now in free fall, hurtling towards the hard, unforgiving earth below. The crowd, gathered in the square below the Leaning Tower of Pisa, held their collective breath, their eyes glued to the spectacle unfolding above them. The air seemed to freeze as the spheres continued their downward journey, the anticipation of the outcome growing with each passing millisecond. The larger sphere, heavier and more imposing, seemed to bear the weight of the world, a representation of the long-held belief that heavier objects fall faster. The smaller sphere, in contrast, seemed almost light-hearted, a symbol of Galileo's audacious challenge to centuries of accepted wisdom. In this moment, time itself seemed to stand still. The spheres spun and tumbled through the air, each rotation a testament to the laws of physics being put to the ultimate test. The world below waited, the tension palpable, the silence deafening. And then, impact. The spheres met their fate, not with the expected staggered thud of differing weights, but with a simultaneous resounding crash that echoed through the square. The crowd gasped, the reality of what they'd just witnessed slowly dawning on them. The spheres, regardless of their weight, had hit the ground at the exact same moment. Against all expectations of the time, the spheres hit the ground simultaneously. This single moment, this simple experiment, had shattered the long-standing belief that heavier objects fall faster than lighter ones. Galileo had proven, with two spheres and an iconic tower, that in the realm of free fall, weight is irrelevant. The laws of physics had spoken, and they had spoken loud and clear. The world, as they knew it, had just changed forever. Why did the two spheres fall at the same speed, you ask? Well, let's dive into the heart of this question, the very essence of Galileo's revolutionary experiment. Aristotle, the ancient Greek philosopher, had for centuries held sway with his belief that heavier objects fall faster than lighter ones. It was a concept that seemed intuitive, but it was Galileo's daring and curiosity that put this theory to the test. He challenged the status quo, daring to ask, what if Aristotle was wrong? And so, atop the Leaning Tower of Pisa, Galileo dropped two spheres of different weights, and lo and behold, they hit the ground at the same time. This was a direct contradiction to Aristotle's theory, and it was a pivotal moment in scientific history. Galileo had just shown that the speed of fall of an object was not dependent on its weight. Now, you might be thinking, that's cool, but why does it matter? Well, this experiment was a giant leap forward in our understanding of the laws of motion and gravity. It was a spark that led to the development of a new scientific era. Galileo's findings paved the way for Sir Isaac Newton's work on the laws of motion and universal gravitation, principles that are still fundamental in physics today. Without Galileo's experiment, we might not have understood the forces that keep our feet on the ground, that keep the Earth orbiting the Sun, or that allowed us to venture into the great expanse of space. So the significance of Galileo's Leaning Tower of Pisa experiment goes beyond the simple act of dropping two spheres. It was a defiant act of scientific rebellion, a critical step in human understanding of our universe. It shattered long-held beliefs, replacing them with empirical evidence and paving the way for modern science. And so, we circle back to the original question: why did the two spheres fall at the same speed? Because, as Galileo showed us, gravity pulls on all objects equally, regardless of their weight. Galileo's experiment changed our understanding of the physical world. And for that, we owe him a great debt. But not everyone was convinced. A ripple of skepticism spread through the scientific community following Galileo's Leaning Tower of Pisa experiment. The idea was revolutionary, audacious, and to some downright ludicrous. How could a feather and a cannonball fall at the same rate in a vacuum? It seemed to go against common sense, and many scientists of the time were hesitant to abandon their long-held beliefs. Galileo's findings were met with a barrage of criticism and disbelief. Some scientists argued that the experiment was flawed, asserting that air resistance must have impacted the results. Others claimed that Galileo's observations were biased or inaccurate. The lack of sophisticated measuring instruments during the late 16th century further fueled these doubts. Critics argued that without precise tools, Galileo's experiment could not possibly yield accurate results. The controversy didn't stop there. Galileo's experiment also incited a philosophical debate. His findings challenged the Aristotelian physics that had dominated scientific thought for over 1,000 years. According to Aristotle, heavier objects should fall faster than lighter ones. Galileo's experiment contradicted this fundamental principle, shaking the very foundations of accepted scientific knowledge. The scientific community was divided. On one side were the traditionalists, staunch in their belief of Aristotelian physics. On the other were the progressives, intrigued by Galileo's daring challenge to the status quo. This division led to a protracted battle of ideas, with Galileo's experiment at the heart of the dispute. It took years for the dust to settle. Gradually, as more experiments were conducted and more evidence gathered, the scientific community began to accept Galileo's findings. The controversy surrounding the Leaning Tower of Pisa experiment eventually faded, but not before sparking a wave of scientific inquiry and debate that would forever change our understanding of the physical world. Despite the controversy, Galileo's findings stood the test of time. His experiment marked a pivotal moment in the history of science, challenging old beliefs and paving the way for the laws of motion that we now take for granted. So what's the legacy of Galileo's daring experiment? Well, it's safe to say that Galileo's Leaning Tower of Pisa experiment left an indelible mark on the course of scientific history. His bold assertion that all objects, regardless of their mass, fall at the same rate in a vacuum was a direct challenge to the prevailing Aristotelian viewpoint. His findings disrupted the status quo and set the stage for a new understanding of the natural world. Galileo's work laid the groundwork for future scientists, most notably Sir Isaac Newton. It was Galileo's experiment that sparked Newton's curiosity and inspired him to delve deeper into the mysteries of gravity. This led to Newton's formulation of the law of universal gravitation, a fundamental principle that underpins modern physics and astronomy. Furthermore, Galileo's experiment embodies the spirit of scientific inquiry. His audacious approach to challenging established ideas and his relentless pursuit of truth through observation and experimentation set a precedent for the scientific method as we know it today. But the legacy of Galileo's experiment extends beyond the realm of physics. It serves as a reminder of the power of curiosity and the importance of questioning accepted beliefs. It's a testament to the fact that progress often hinges on the courage to challenge conventional wisdom and seek answers for ourselves. Moreover, Galileo's experiment is a symbol of the ongoing quest for knowledge that drives scientific discovery. It reminds us that the pursuit of understanding is a journey, not a destination, and that each new discovery builds upon the work of those who came before us. And let's not forget the practical implications of Galileo's findings. They're evident in everything from the functioning of a simple pendulum to the complex calculations involved in space travel. Every time an astronaut steps onto the moon, every time a satellite is launched into orbit, we see Galileo's legacy in action. So next time you drop something, remember Galileo and his revolutionary experiment.